Alright, in this video we are going to be talking about intercepts, X-intercepts and Y-intercepts. So let's dive right into the definition of these intercepts and what they are called. So I'm going to go to my answer key because I have these written down already. I'm going to read off of these and then kind of talk about them or summarize them. Right? So X-intercept graphically, the definition is the point where the graph crosses, touches, or intersects the x-axis, and then algebraically is the point at which y, or f of x, the function, equals 0. And then your y-intercept graphically is the point where the graph crosses, touches, or intersects the y-axis, and then algebraically it's the point at which x equals 0. So those are kind of switched. We are going to be writing all of our intercepts as ordered pairs. So our ordered pairs will have 0 for our zero for x for the y-intercepts, and then 0 for y for the x-intercepts. Right? And then one last thing about intercepts, especially x-intercepts, they have different names. So x-intercepts are also called roots, solutions, and zeros. So roots you usually hear with quadratic functions, and that's a later unit, so we'll talk about that again when we get to that unit. They've been called solutions because they make the equation true. You could put that solution back in, and whatever it's supposed to equal is the same as what you get when you work it out, so it makes the equation true. And then they're also called zeros because if you put that in to the function, the y value is 0. So you may see it say find the zeros, or find the solutions, or find the x-intercepts. Moving right along. We're looking for the x and y-intercepts on the graph. So on the graph, I just need to find where it intersects the x-axis and the y-axis. So on the x-axis, I can see is this point right here at 2, 0. And then on the y-axis, it's at -3, 0. It's going to show the answer for number 2, and that's okay. And we write these intercepts in ordered pairs, so 2, 0, and 0, -3. And then for number 2, it has 2 x-intercepts and 1 y-intercept. So I can see it crosses the x-axis here and here, and then it crosses the y-axis, here. So I can say my x-intercepts are at 4, 0, and 2, 0, and then my y-intercept is at 0, 8. Scroll that down just a little bit so you can actually see that. And just to kind of review kind of everything that we've been talking about this unit, I could do the vertical line test here and this would pass. It is a function. I could do the vertical line test here, and even though it looks like it might touch more than one point, each line only goes through each point on the function once. But this point down here, when I do the vertical line test, it is not a function. But even though it's not a function, I can still find the x and y intercepts. And not everything we graph, well, in this class, everything we graph will be a function. But in other classes, you may graph a circle, and that's not necessarily a function because it doesn't pass the vertical line test. But in this one, I can see that this intersects the x-axis at 2 places, and it intersects the y-axis in 2 places. So this would have 2 x-intercepts and 2 y-intercepts. So -5 and 5 for your x's, and -5 and 5 for your y's. Now the rest of those answers are up there, but I'm not going to go through every single one. I just wanted to show you a couple of those. Now we're going to do a couple of these by hand. To do this by hand, you have to remember the definition, the algebraic definition, the point at which x equals 0, the point at which f of x or y equals 0. So for number 1, it doesn't really matter which one you do first. I'm going to try and keep this kind of color-coded, so anything in purple is going to be x-intercepts, anything in blue is going to be things for our y-intercept. So let's do our x-intercept first, and I need to set y or f of x equal to 0. Well, f of x is here. Let me change the size of this. So if I'm changing f of x to be 0, that means this is just 0. I'm not saying f of 0 because that would mean x is 0, and I just want f of x to be 0. Once I do that, I can go ahead and solve this for x. So that's step 2. Right, and to solve this for x, I need to add 8 to both sides. So I end up with 8 equals 4x, and then divide both sides by 4. That was supposed to be a 4, it doesn't really look like it. And I can say 2 equals x, or that our x-intercept is 2, 0. Right? So that would be our x-intercept of this, and then I could check this, put 2 into x. 2 times 4 is 8. 8 minus 8 is 0, and that works out because y is 0, or f of x is 0. Now, if we want to find the y-intercept, I need x to be 0. So I'm putting f of 0, which means x is 0. And anytime I see an x, I'm going to put in 0. Oops, that was supposed to be 0, not x. The y-intercept is a little easier to solve for because in this case, we know anything multiplied by 0 is 0. So that means this is just 0 minus 8. 0 minus 8 is just negative 8. So I can say the y-intercept is 0, negative 8. Right. I'm going to do one more of these, one of the ones with fractions, but really when you're solving this algebraically, it's almost like you were solving for the variable, solving for the equation. The only thing you really have to remember is that you are putting in 0 for x or for y, depending on which intercept you're solving for. So in this case, let's do number 6. Now the other 4 are solved already on the answer sheet, and if you are having difficulty with any of those, just message me and we can work through those. Alright, so I'm going to do this a little backwards. I'm going to start off with the y-intercept this time. So with the y-intercept, x needs to be 0. I'm typing this, so I'm going to leave a couple spaces because I have to write in the fraction. This notebook that I'm working in doesn't really let me type in fractions. Oops. So this is going to look kind of funky for 1 second. Just bear with me. Okay, so this is supposed to be -2/5 times 0 minus 4. And just like in our last example, anything times 0 is 0. So here we're going to have f of 0 equals 0 minus 4. So f of 0 equals -4, or the y-intercept is at 0, -4. Okay, then we can go back and we can solve for our x-intercept. Okay. And with our x-intercept, f of x needs to be 0, and we need to solve for x. Again, I'm going to leave that space so I can type that in. Oh, I'm sorry, I just realized this was +4, not minus, so I did that a little backwards. Let me go back and fix that before I start on this one. So this was supposed to be +4. My apologies, I did not see that. I think my box was on top of the line, so it looked like it was just minus. That's an easy fix though. Okay, so 0 plus 4, so f of 0 equals 4, so the y-intercept is 0, 4. Now that that's fixed, that was supposed to be a 2, it doesn't really look like one. Okay. And here I need to get x by itself, so the first thing I'm going to do is subtract 4 on both sides. Man, I'm glad I caught that because that would have messed our entire problem up. So then we have -4 equals -2/5 x. I just have to go back a little bit, or go back and forth a little bit between the pen and the typing. Right? And then you should remember that anytime you have a fraction next to your variable, you can do a couple different things. You can multiply both sides by the denominator and then divide both sides by the numerator, or you can do them both at the same time by multiplying this entire side by the reciprocal, or by this fraction flipped. But what you do to one side, you have to do to the other. Those are supposed to be parentheses. So when I multiply -5/2, or -5/2 times -4, I get +20. I'm multiplying my numerators, and then I divide by 2, so +10. So 10 equals x, or our x-intercept is 10, 0. I'm going to space that out a little bit more. Okay, so that is solving algebraically. Excuse me. Now I'm going to show a couple of the ones on the calculator. I'm going to show this using the graphing calculator and then on Desmos. You'll find that Desmos is easier, but for those of you that have a graphing calculator, use that. You can use Desmos even if you have a graphing calculator. I was just saying if you want to use that. Alright, so we'll do two examples, both in the graphing calculator and on Desmos. Alright, so I have my calculator pulled up, and we're going to go ahead and do this first example. So I'm going to go into y equals. Now again, I'm on my color calculator screen, but if you're using just the regular TI-84, this will work just the same. And go ahead and put in x squared minus 16. And then I want to go ahead and graph it. So I'm following these steps. I enter the function, I hit graph, and I can see part of my graph. Now, here is kind of where this optional step 3 comes in. Here I can see that my x-intercepts are here and here at 4 and -4. If you can see your x-intercept and your y-intercept very clearly, you don't have to do any of these from the optional step 3. If you can't quite see the exact value, this is where this comes into play. Now, I see that this is on -4 and 4, but just to make absolutely sure, I could do this. So I'm going to hit second trace at the top, and then really for this, for your intercepts, you want two different things. You either want the value or you want the 0. Remember, 0 means x-intercept. Your value is going to help you determine your y value at a certain x value. So I'm going to do the zeros first. So I'm going to click number 2. Let me make this a little bigger now that we have the thing. Okay, so it asks for left bound. You can only do one of these at a time, so that's where it's a little time consuming. But let's say I want to do this first. I want to make sure that this is at -4. I need to pick a number that's left of this. So any number to the left of this. It could be -4.5. It doesn't matter, as long as it's to the left. I'm going to say -5, and then I'm going to hit enter. And then a line is going to appear. Even in the regular calculators, a line would appear. Then it asks for a right bound. So I need a number that is right of this 0, but that doesn't go past this one. So somewhere in here. It doesn't matter if I do this value 0. It doesn't matter if I do something very close. I'm going to go ahead and say -3, and I'm going to hit enter. Another line appears, so now I see that the 0 I'm looking for is in between these two lines. And then it asks me to guess. So that's if you want to like try to pinpoint what exactly the 0 is. I just want the calculator to do the work, so I'm going to hit enter again. And it's going to tell me that I have a 0 here at the values -4, or at the order pair -4, 0. Now I'm going to do the same thing for this one. Even though I see that it's crossing the x-axis at 4, I just want to double check. I almost said double short. Double check to make sure, there we go, that this is at 4. So go back to second trace, go back to 0, and I want a left bound of this 0 now. So I can choose any number inside here that does not go past this line. So I'm going to say 0. Now, of course, you could have chosen 3 or something closer, and that's fine. And then for my right bound, I'm going to go all the way out here and say 8. Now, you can't really see this line because it's on the y-axis, but now I have my two lines, and this 0 is still in between those two lines, even though it's a little bit more spread out. I don't want to guess, I want the calculator to do the work, and it again tells me there's a 0 at 4, 0. So now that I have that part, I have my x-intercepts. I figured them out, I found them. And again, you don't necessarily have to do that. It's good to double check, yes, but if you can see clearly that this crosses this line at 4 and -4, you don't need to do that. Now, here I can't see my y-intercept, so you have a couple different options. You can zoom out, you can change the window, or you can do what it says on the notes, which is go back to second trace, go to value, and you see a screen that says x equals. Well, if you're looking for the y-intercept, what does x have to be? 0. I'm hoping that's what you said. So I put in 0, I press enter, and the graph doesn't move, but it will tell me that my y-intercept is 0 when my y-intercept is -16 when x is 0. So that is one way you can use your calculator. I'm going to go ahead and write those answers down before I go ahead and do it in Desmos. So I wrote zeros instead of x-intercept, but remember that's the same thing. So the zeros were at -4, 0, and 4, 0. And then the y-intercept was at 0, -16. Now when it comes to the quiz or the test, if it says to do it algebraically, then you have to show your work. But if it doesn't say that, and it just says find the zeros or find the y-intercept, then you can use your calculator or Desmos to find those. And you can do it algebraically if you so choose. So I'm going to put that same one into Desmos. So I'm on Desmos, and I'm just going to go ahead to my first line and type in x squared minus 16. Notice that it graphs it for you. And I'm going to go ahead and zoom out so I can see everything. And what's nice about Desmos is that I can click on the points that are x and y intercepts, and it will tell me those points for me without me doing much work on the calculator or Desmos or anything. So -4, 0, 4, 0, 0, -16. And done. Right? Now, let's do one of these ones down here. Let's actually do two of these, because I want to do one of these ones to the third power, and I want to do this last one. So I'm going to go through the calculator step with the x to the third one more time just to make sure you got it, and then number 10 I'm just going to go ahead and put that in Desmos. I'm going to split screen this just for a second. Maybe. I have a bunch of stuff open, as you can see. Alright, so go back to y equals and put in, let's do number 7. So x to the third power minus 5x squared plus 2x plus 8. Alright, so x to the third minus 5x squared plus 2x plus 8. Then I'm going to go ahead and graph it. Right, so I can see that there's a y-intercept. I can see that there are now 3 x-intercepts. And this happens to go directly through these values, but I'm just going to double check just to make sure. So second trace, I want 0. Left bound, I'm going to start at this 0 and work my way to the right. So left bound of this, I could say -2. Right bound of this, I can say 0. It's in between, hit enter. One of them is -1, or one of the zeros, which that's what it looks like. On to the next one, do a 0. Here, I need a left bound of this, so I'm going to say 1. A right bound of this, I'm going to say 3. It's in between these 2 lines, so I'm going to hit enter. It says my 0 is at 2. And then last x-intercept for 0. Left bound of this, I'm going to go ahead and say 3. And then right bound, you can choose any number over here, so I'm just going to go ahead and say 10, just because. Now, this line is like right on the edge, but it is there, so it's in between these 2 lines. So I'm going to hit enter. And my last 0 is at 4, 0. Now, if you wanted to take a function that maybe wasn't exactly on the x-intercepts, or like on the lines exactly, so what if I'm going to change this just a little bit by adding in a coefficient. Oh, that didn't help me. I probably shouldn't have added it there. Let's make this a plus instead and see what that does. See, that looks like it's kind of not on the line, so I could do that 0 there and see what that is. Yeah, so this one is not exactly on -5, but it's really, really close. This just means it's really, really close to 0. There are 12 zeros in front of this. But that would just give you an example. Let me go back and make this what it was actually supposed to be. So now we can find our y-intercept. Second trace, go into value. This value must be 0. And it's set. Now here, it also looks like I could have just counted. But just to double check, when x is 0, y is 8. So again, I'm going to go ahead and write that down before I do it in Desmos. It was like a double screen there for a second. That was weird. Right, so we had 3 zeros at -1, at 2, and at 4. And then our y-intercept was at 0, 8. So now let's go ahead and put this in Desmos so you can see what that looks like. X to the third minus 5x squared. As I'm typing in different coefficients and variables with different exponents, you can see this graph change a whole bunch. Plus 2x plus 8. And I'm going to zoom back in just a little bit. And here, now there are 2 points on here. One we are going to cover when we get to quadratic functions, but just to kind of put this in your mind now, that's going to be your maximum point, or a maximum point. But that's not what we're looking for. We're looking for that 0, 8. That's also why this one is highlighted, because this is a minimum point, but we are not going to talk about those in this lesson. Right? So our 3 zeros and our 1 y-intercept is there. Right? And then in this last example, so I have it written off to the side here, x to the 4th plus 2x to the 3rd minus 25x squared minus 50x. So this is number 10. So I'm going to zoom out really fast just so you can see what this weird function looks like. So it goes up, and it goes down, comes back up, and it goes down, all the way down here, and then goes back up. Alright, zooming back in. Okay, because I don't really need to see this point because it doesn't cross the y-axis here. So really I just need to see where it crosses the y-axis and the zeros. So I'm going to click on the function, and I can see what lights up. This, 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 and this. Now here, because the origin, or the middle of the graph, is a 0, it's also a y-intercept, because when x is 0, y happens to be 0. So those are your zeros and your y-intercept. Let me write that down really fast. So I can put that on this. I know these aren't the values for the x-intercepts and the y-intercepts. I'm just cheating a little bit by not typing. Okay, so we had -5, -2, I guess I could have kept that too. We had 0, 0, and then we had 5. And then for our y-intercept, we had 0, 0. So there are problems that we did not go over on doing them by hand, doing them in the calculator, or on the graph. But if you have questions, you can message me and we can work through those. And the answer key is also posted.